Okay, hello everyone. Today I'm going to participate in the Codeforces round from Neowise Labs. Yeah, I'm going. It's unusually short for the combined rounds. Of course. Deprecation. Okay. Huh? What the heck? Okay, that's okay. Like this, right? Okay. Okay, so it's basically unique. Do we just go and do this? Okay. Okay, at least K. Okay. Oh, different colors. All right. Mm-hmm. Okay, also kind of straightforward. We just we'll just get the all the maximums, and some of the minimums and plus one. So vector pair in vector pair int a of n. If I is less than k minus 1, then this, pardon me, also always do this. Okay. So it's basically like all these problems, like how many balls do you need to take out at least so that you would have like all the colors or something. Okay, is it ever impossible? Okay, here it is impossible. Because yeah, I don't really know. I think this says basically that we need to hire like one of these people exactly once. this says that one of these people exactly once, and what like, do we always not succeed? This says we can't hire this and not this. Okay. So we have three types of restrictions, right? Like implications, and two types: implications and XORs. Yet I don't want to do too sad. I think these are just two fairly straightforward TPs. long ans equals f equals 0, then we transpose Okay, now we need to calculate 0 is about rows. Okay. No, thanks. Now, if we hire this person, now for this, okay. Nope. Can I do this? Can you please? Can you please? What? Nice. So can is true, 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 true. Or it is greater than the candidate and tmpc equals candidate. What is wrong this time? My bad. Wrong answer. My answer is now what? What? Because yeah, I can't say minimum. Wow, okay. This is problem C, right? Okay. Two integers. Okay. Flip blah blah blah. What? Yeah, okay. Yeah, that's much easier than C. Yeah. So yeah, you get the parity of you get the parity of so basically after every operation. No, it's not easier. I only don't know the parity, right? Yeah, but it should be, there should be some other sort of invariant for this. Like, what if for every light bulb we take its x coordinate times -1 to the x plus y? I think that's yeah. every wait, I don't know what happens on each operation. Probably nothing. Okay, can I just XOR it? XOR. Yeah, the total XOR of X doesn't change. So yeah, it's problem D. Okay, I don't just want to think. I will just use like something like this. Let me think a little bit. Okay, I need to be a little bit more subtle. N is even, by the way, right? It doesn't say this, but okay. I mean N is odd. Yeah, sorry, I meant this. Correct answer this. My answer -4. Why? Yeah, what if there are multiple solutions? Print any of them. But why? I thought my solution is unique and it's not the same as this one. Yeah, of course, -2 should be the correct answer. But why? Wait, what? Why -1 and why? Fuck. Yeah, and actually my answer would be correct, but this doesn't change anything, right? Does it? Well, except that I like don't know. Okay. If I consider instead of x, y something like x plus y, x and x plus y, right? What the fuck? No. Why? So in my new coordinates, where instead of y we have sorry. Yeah, now I cheesed it. Wow. Wonderful. I want to close this. Wow, I'm a bears. Okay, so sort the binary sequence, right? Okay, we can sort the sequence of size, a subsegment of size 3. KB is less than P, which is convenient. Okay, basically what this sorting does is like if you have BPB or PBP, we just move something one, like by a distance of 1 to the direction we want, I mean to the correct direction. And if it's BPP, for example, it's already okay. It's PPB, I mean we move it 2 to the correct direction. So yeah, basically we can assume that we always can move in one move. We can either move a black 2 to the left or a pink 2 to the right, or maybe 1 if we want to. It doesn't make sense to rush this movement by 1, but like yeah. Okay, first of all, let's say that we only move blacks to the left. So now we have 0 or 1 pink, then some number of blacks, and 0 or 1, yes, and 1 pink, some number of blacks, 1 pink, some number of blacks, etc. After that, we can try and move the rightmost pink. Yeah, we can similarly all these pinks try to move to the right. So we will have, in the end, we will have something like some blacks, then something like this. In this case, what should we do? Yeah, we can do this. Oops. After this, it will be this. Yeah, it will just do something like this, like in linear number of moves we can do something. Can we do it faster than in linear number of moves? I'm inclined to say that we cannot, but I don't believe it so much. Or do I now? Wait. There should be some sort of, like most of the time we, on each operation we change the number of inversions, we decrease it by either 1 or 2. But obviously we need to decrease it by 1 as few times as possible. There is probably some sort of invariant to, I mean, same invariant that lets us find out, like estimate, like bound the number of these things. Like what if we consider for every black element the parity of its position? They should alternate, like go even odd, even odd, even odd, and so on. In one go, and the same with pings, right? In one go, we do not change, by decreasing the number of inversions by 2, we do not change the number of blacks on even positions or pinks on even positions or something. Yeah, so yeah, I'm so stupid. Oh god. In one big step, we swap two elements on positions of the same parity, so one bound would be like the number of say blacks on even positions minus the number it should equal, like by difference by absolute value. And why does our algorithm achieve this number, achieve this bound? So if we have something like pink, blacks, pink, black, pink, black, 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 pink, black, pink, black, pink, 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 pink. Yeah, because we only did like, actually we did it from left to right, so yeah, we shuffle this while we can, however we can. Yeah, this just will go wherever we want it to go. Yeah, okay. So we count the number of inversions, and n equals nxt. I don't really, do I care? Do I don't. I do. Okay, nxt string s in c p equals 0. For cs if c is b, infs plus equals cp, otherwise this. Now okay, now I want to say that constant need even is b plus 1 over 2, even is 0, okay. Yes, thank you. I'm kind of confused, like, if I'm correct, which I like don't see why not. Did I miss? No, I don't think I missed any like int overflows. Then I don't understand why problems C, D and E are like arranged in this order. because E is easier than D and D is easier than C and C is also not that hard actually, but I must say the testing speed is, I think, unusually fast, unusually big. Yeah, I can just go read the next problem. Okay, so Among Us. Okay. Thanks. Okay, understood. So can it be that these statements are all true and every statement says that either this is all zeros or these are not all zeros? So if it can be true, then we can just take the all zero statements, say that they are all zeros, then say that however we aren't sure about yet are all ones. And yeah, so we basically want to check if there is any like statement of type 1 whose segment is entirely within the union of the segments from statements of type 0. Well, one way to solve this, no, not really. I wanted to say that it's like more algorithm with some Fenwick tree type of thing, or like segment tree type of thing, but first of all it's too slow, I think, and second, well, okay, it can be pure n square root of n, but, or rather m square root of m plus m square root of n. I don't know yet how to solve this. Like every time we need to actually check something, what do we do? We probably don't check every one statement of type 1, right? Okay, let's think. But it's nice to remember that we have this in our arsenal. Oh, wait, f and g cost the same, so I can probably read problem g also. Sounds like some very well known and studied motif from the information theory. Okay, k is even, so she can give us one of 3 outcomes. Oh my. Assume that she doesn't ignore anything. How can we speedrun this? Well, if n is a power of 2, or rather, if n is even, yeah, okay, we can just assume that we have a tree, a binary tree of what we ask. Then, I'm getting familiar vibes. Then, okay, if n is even, then we can just ask. If n is odd, we just discard the last element. Okay, we ask. Yeah, okay, I found a way to do this in log n. Like, first we ask just about all the elements. Okay, we have, similarly, we have some ternary logarithm, like if n is a power of 3, for example, or whatever, doesn't have to be a power of 3. Like, we divide it into 3 about equal parts. First we ask like about the first 2 of them, then for every possible outcome, like where it is, we divide every part in 3 about equal parts. Yeah, not like this. Okay, with some 2 weeks, we ask about first like all left parts, then about all middle parts or something, and so on. What I don't like about this is that we want this left house and right house to be the same. Yeah, okay, I can do this. Can make everything symmetrical, I think. Okay, that is some poor man's way to enforce this. So, if she wouldn't ignore anything, she didn't ignore anything, we would do this. Unfortunately, I don't remember what to do when she does ignore something. Okay, so okay, we asked few questions. She can respond with like q times 3 to the q minus 1 different outcomes. Every possibility has q outcomes per possibility. Each outcome must correspond to exactly one possibility. Therefore, there should be a way to do this in logarithm of 3 plus 1 or something. Okay, assume that she didn't ignore, like we asked whatever we want to ask. If she doesn't ignore anything, and plus something else we haven't decided yet. If she ignores the first, okay, she doesn't ignore anything of this, any of this, then okay. If she does, then like whatever she ignores decides like okay, we have like 3 different possibilities. If we if she ignores this, like yeah, I think it should be something easy. Can we just can we no, I don't think we can, like assume that we included some number in some part, left or right. We don't need, we must include its counterparts in the different parts. Okay, there is always, no, it's not symmetrical guy, right? Okay, if it was a power of 3, then it would be something like for every number, its ternary neighbors must be indifferent. Yeah, we would just paint every number into color like the sum of the choices modular 3. Oh, wait, we can do this here, right? I think it will be, there will always be something like some 2 guys of equal counts. Okay. N is NXT vector Okay, now I want to do what? To run some sort of GFS, right? I wonder if interactive problem works well with 279. Okay. I will call it GFS because that's kind of what it is. Nope. Oh wait, current sum by sum of cur pushback L return also level while QRS size at most level but if it's 2 modular 3 then this. Yeah, I probably should say something like okay. Pushback L plus I R pushback R minus I plus I. Okay. Now self of self L plus side level plus 1 cur plus can't say just cur R minus side R L plus side R minus side. Yeah, wait a minute, can it happen that it can happen that it's actually an empty part? Okay, GFS of GFS from 1 to n plus 1, current level is 0 and current sum is also 0, which doesn't actually matter. Okay, and I think that actually I'm not sure. Okay, let's say assert that okay, I don't believe this, so let me just wait, what, really? Whew. Wow. Nope. Yeah, arithmetic I plus 1. And what do I do with it? Okay, 59. Okay, that's insane. Can I assume this? No. Can I assume this? Of course no. Can I assume I know this? No. Okay, okay. While by some t size doesn't equal plus t, okay, whereas L pushback by some t, whereas R, okay, okay. Can it happen that actually have different depths for them? Okay. I do not care at all, but let me probably. Yeah, okay. I should probably construct the answers for them. Yeah, okay. I want to do this here, and I want to say that is it guaranteed that S has exactly one question mark, because it says here exactly one. Okay, also no hugs. Anyway. Let me okay. Int qm equals as find question mark. I thought qm isn't -1. If okay, let's check. First it says n equals 3. It says as I'm sorry, what do you think you are doing? Okay, I kind of believe this. Indeed, this is what I wanted. So, what did you... Yeah, they guessed like 3. So I should, like, for example, ignore the first one and say R for the second one. It's 3. Okay. Now... Okay. Now I say 5. They say 3. Some numbers. Okay. The answer should be 1. But I don't like. Okay. If the answer is 1, then I would say LLN. Let's say L question mark n. Okay. Seems working. So let's just submit this. I wonder if it has been submitted. Like, it can show me the notification in the bottom right corner, like wrong answer 2 or... Okay, it has been an hour. I would say that so far so good. but I haven't seen the standings page. I don't want to read problem H because it's, well, maybe. I think it's well known in Japan, or like I have seen something similar on at Coder. Okay. Okay, problem H is well known in Japan. I mean, 39. It's not like he's so smart. It's probably he copy pasted it from AdCoder. Problem F also seems solvable. So I got that impression from reading it as well. Also, I had some divide and conquer ideas. Such as no, it doesn't work like that, I think. Yeah. Okay, I'm missing something. Okay, even if it's easy to keep track of all zero statements, it's not clear to me right now how to keep track of not all zero statements. Or we can say something like, if we have a graph and we look at what is reachable from what is not, but usually these types of statements are converted to simpler ones. Where I don't see it. I can see it. Yeah, that's because probably it's somewhere here. Like the problem names are too long. No, it's not XOR sum. XOR annihilation. Ah, no. Main XOR. Range XOR. I don't think that orange. Yeah, it's not. Probably no. Probably this is because about that hashing stuff. No, it's not. But BPB from AGC. Here we go. Gain incremental XOR. Nope. RNG. Replace. Okay, anyway, stop this. I want some way of knowing if these segments cover all this. How can I know this? I need some tea. I am not closer to this solution, I believe. Okay, if we have a predicate to find yeah, I just want maybe for yeah, of course mo is not needed here. I could just as well for each element find the maximum error so that statements from L to R are still non-contradictory. Yeah, however, I don't know how to find okay, so for every statement of type 1 what doesn't suit us is a segment long enough to cover what suits us is for each element of this subsegment we find like the previous statement of type 0 that covers it and the next statement of type 0 that covers it, and we take this segment, right, and we basically say that for every statement of type 1 if we get the union of this still is okay with us. Anything that is not within this union is already bad. Am I right? No, I'm not right. Okay. No, that's so painful. Okay. Okay, back to what I wanted to do with these predicates and stuff. Okay, I can in logarithm what? No, probably not. I can somehow. If I have, okay, I can find this, I believe, somehow. Yeah, I can. Okay, so that we have fixed the like L. Do we want to kind of find the maximal R that is okay? Can we, like, for a statement of type 1, or rather for every position, we kind of know when it is going to become guaranteed to be 0, and then just kind of with, yeah, okay. What happens when we move L, like increase it by 1? Okay, if it was a statement of type 0, then just for a bunch of numbers, yeah, I want to move it, like, to decrease it by 1, then yeah, for a bunch of numbers this becomes L for a bunch of positions, and then what? If we currently had some R, like the first contradict, if this R was of type 0, then yeah, Okay, if we only had one element, no, this is very dumb. Okay, kind of. Assume that for a statement of type 1, we want to extract some information like we know when each of its elements was touched by a statement of type 0, like the previous time and the next time. Okay, so what? Okay, some statement of type 1 can be ruined on some queries. How can we find this? How can we find these queries? At least one imposter. Okay, by binary searching something, I can maybe it will be an log squared. No, I don't believe it. I don't like the idea to consider each element separately, because I find it hard to then reduce like nm. Really don't like it. I want some duality to kind of... Currently I don't like that the statement of type 1 I can only check like explicitly. I cannot remember something and notice when it breaks. Why can't I? Or maybe can I? Can I say that each of them kind of corresponds to like a logarithm of subsegments, which when they are eliminated I would like to notice. Yeah, however, I don't really know how to do this. Cannot do the two pointers thing. At least I don't see how. Cannot roll back easily. Can? Yes, I cannot handle events of type wow, this element is now necessarily 0 by one element. Okay, can it happen that people get problem H more than problem F? The same amount. That is so cursed. Mostly, yeah, Japanese people. Can I quickly switch and like get it in 10 minutes? What if all lower bounds were equal to 0? Okay, we want like one big convolution. For each number we want to find like for each n, for each of these n numbers, and I mean segments, how many had like an even number of bits from this number x set minus how many had an odd number set. Then we want to multiply them all together. How can we do this? We probably can't, or I don't know. Okay, each segment can be split into maybe 36 segments of sort this first number of bits are fixed and all the others can be whatever. And yeah, so if we pick some of them, then we will have something like, if we pick some each of them, so that the maximal number of the trailing bits that can be whatever we want is k, then we will just have to get some convolution of what the others, the prefixes can be. This convolution is much smaller, it's like it's most 2 options per n, so we probably can come up with something. Yes, and anyway, yes, after this we will just say that for all the resulting numbers we just say like plus equals something, right? Oh no, it's no longer 2, it's maybe 36 options per element. But anyway, I will not be able to implement this in 3 minutes and I don't have a final solution yet, but I think I'm pretty close. Okay, I should have gone with this problem first. But who knew? I mean, I would know if I were to like refresh the page. Okay, do I want to maybe hack something? Yeah. Yes, of course. I will not even be surprised if he gets it accepted. Or she. Oh, okay. Okay. In my room, I'm the first. Nice, but nobody really solved anything. What the fuck? Okay. Yeah, I don't really know what to hack here. Problem B? Probably no. Problem C? Probably no. Or problem A? Probably no. Okay, but I have like 40 seconds. Problem B. Lock it. Okay. 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 Yeah, okay. Yeah, this has been fun until problem F. I should have gone with problem H, but yeah, it's a shame that it was such a well-known problem. It also was a shame that surprisingly problem G is solved about as much as problem F or problem H. They are kind of balanced. Yeah, maybe I just don't see something. Anyway, that's it for today. Thank you for watching. See you probably tomorrow at Coder Grand Contest, although even if I record it, I will probably, it will not be entertaining to watch, but we'll see.